Hello viewers, in today's session we are going to discuss another important problem from indefinite integrals, and in this session we are going to evaluate this important indefinite integral where we have integral x square plus 16 divided by x raised to 4 plus 256, and here we observe that the numerator is a quadratic function and the denominator is a biquadratic function. So now let us call this integral as I and our integrand as f of x, that is x square plus 16 divided by x raised to 4 plus 256. Now if we closely look at this integrand, then we can easily make out that this integrand is of the form that is x square plus a divided by x raised to 4 plus a square, where a is 16 and a square, that is 16 square, is 256, right? So we can claim that this integral is of the form that is x square plus a divided by x raised to 4 plus a square dx. So we'll see in this session how we can evaluate integrals of this type. So the first step in evaluation of these type of integrals is to divide the numerator and denominator by x square, right? So now let us divide the numerator and denominator of this integral I by x square. So we can now write I is equal to x square plus 16 divided by x square, and here we have x raised to 4 plus 256 divided by x square, and here we have dx. So now we can write this expression as 1 plus 16 over x square, and in the denominator we can write x square in the denominator of x raised to 4 and 256. So here we get x square, and here we have 256 over x square. Now the second step is to make use of the method of substitution, and here I will make this important substitution, that is t is equal to x minus a over x, right? So this is our substitution where t is a function of x, and here the value of a is 16. So we can now write t is equal to x minus 16 over x. Now differentiating t with respect to x, we have dt over dx, and the derivative of x is 1, and here we have minus 16. The derivative of 1 over x is minus 1 over x square, and that is equal to 1 plus 16 over x square. So now we can write dt is equal to 1 plus 16 over x square dx, right? So now we can replace this expression by dt. Now let us take care of this denominator, and in the denominator we have x square plus 256 over x square, and now our aim is to express this quantity in terms of t. So we'll make use of this equation, and we can take the square of both the sides. So we can now write t square, and here we have x minus 16 over x square. Now taking the help of this identity, that is a minus b square, we have a square minus 2ab plus b square. So here we can now write t square is equal to x square minus 2 times x times 16 over x, and here we have 16 over x square. So we can now write t square is equal to x square minus, here x and x get cancelled. So we are left with 2 times 16 is 32, and this is 16 square is 256 divided by x square. Now taking this term to the left hand side. So taking minus 32 to the left hand side, we can now write t square plus 32 is equal to x square plus 256 over x square, right? So now we can replace this expression with the t square plus 32. So now our integral I takes the form in terms of t. So for this expression we have simply dt, and in the denominator we can write simply t square plus 32, and here we can write dt, and here we have t square, and 32 can be written as the square of 4 root 2, because the square of 4 root 2 is equal to 32. So now our integral I is of this form, that is integral dx over x square plus a square, and here the difference is that we have the variable t, and for a we can write 4 times square root of 2, and this integral is a standard integral in indefinite integrals, and the value is given by 1 over a tan inverse x over a, right? So now this integral I can be written, or it can be expressed using this result. So now the value of this integral I can be written with the help of this result. So we have 1 over a is 4 root 2, then we have tan inverse t over a is 4 root 2, and c is the constant of integration, right? So here this integral has the variable t, that's why here we have the variable t. Now again replacing this t by x minus 16 over x, we can now write 1 over 4 root 2 tan inverse x minus 16 over x divided by 4 root 2, and here c is the constant of integration. So now simplifying this expression, we can finally write the value of this integral I as 1 over 4 root 2 tan inverse, and here x times x is x square. Here we have minus 16 over 4 root 2 x plus c, right? So this is the required value of this integral.